and the floor is yours.
Okay, thank you. So, hello everyone, both there and online, etc. My name is Emil Alégroth. I am not there, obviously. I'm currently in Gothenburg, even though I think I heard that I was in Borås. It's not completely wrong. I'm somewhere in between Gothenburg and Borås, if you people know where those two cities are on the west coast, in Bollebygd. Anywho, I was hoping to be down in Växjö with you guys, but unfortunately, as you know, it's autumn, so therefore our tiny little kids and stuff, if you have those, like bringing home plagues from daycare, and I caught one of those. So I decided that it would be better not to spread it to you guys. So therefore I'm at home. But hopefully you will enjoy this presentation anyways. It's a joint presentation that me and the other Emil in our team has developed together. So we are the Emils, and we're going to talk about on the economics of software testing. So let's get into it. So the disposition for today is that I'm gonna give a little bit of a background for the studied area about economical models and testing, and then I'm going to present our take on this whole subject and why and how we differ from previous literature research in the area. Once more, this is about modeling. We've heard a lot about modeling today, so here's a little bit more modeling, but economical modeling in this case. And then also some preliminary empirical results that are connected to the results that we have collected. So first, a little bit background. So software engineering, as we know, is a rather young subject area discipline if we compare it to, let's say, mathematics, physics, even computer science. And a lot of the research that is being conducted is still very focused on technical aspects, technical research into tools, processes, and so on. In recent times, there has been a little bit of a shift towards more managerial research. We have, for instance, the insurgence of behavioral software engineering, where we're combining psychology with software engineering to look into software aspects and human factors that influence software engineering. And of course, there is a little bit of different use of this in different parts of the field, but in general, we have started to look into a larger picture of how software engineering works together. And we've heard excellent examples of this today from Michael, for instance, with how humans interact with one another and so on, right? So software factors in software engineering. However, my research topic is primarily software testing, and in particular, automation of testing. And when it comes to software testing, this subject is still extremely focused on technical aspects. Most of the research in software testing is still about how to do automated testing with different tools and practices for that. There is very little research into other aspects of software testing, such as the aforementioned human factors I just mentioned. So instead, it's more emphasis on tools and maybe how to integrate said tools in a continuous integration environment and so on. But still, there is so much other aspects to explore. And one of these things is, of course, economy. With that, I'll get back to. But the question is then, why are we testing? What do we test and why do we test? Well, the main idea with software testing is that we do quality assurance of our software system before it's being shipped, right? We want to verify that the software that we've developed adheres to both its functional and non-functional requirements. And to do so, we can do this in different ways. We, of course, have manual testing that we can use, but in recent years, there has been a larger and larger push towards test automation, creating test cases or test scripts that can automatically do regression testing for us in different ways, often integrated in the aforementioned continuous integration environments or continuous ways of working that Eric was talking about earlier today, and thereby creating this autonomous system for quality assuring that our system, when it gets out to our customers, that everything seems to be working. But when it comes to testing, there, as we know, as industrial, at least our industrial practitioners in the room knows, is that there's a lot of trade-offs that needs to be done. When you're developing software, there is always this timeline crunch, sort of, there is always deadlines. Even in an agile environment, there is always a deadline. We need to be done with the entire system at a certain date. And there is always then this prioritization of how much testing can we do, how much development is left to be done, because in essence, we seldom can test before the development is completed, right? And there are, I say seldom, because there are some approaches, as you know, like test-driven development and behavioral-driven development, where testing is sort of written before, or automated tests are written before the code. But in general, you need to have the software in place, and then you create the tests, right? So when it comes then to scaling of testing and this push towards continuous automation of testing and verification of the entire system, from low levels with unit testing to integration testing to system tests, and even discussions about automated acceptance testing, then there is this need then to scale the software testing and to find a way of finding defects as efficiently as possible, as early as possible, or at least just in time, right? And so why this trade-off? Well, the main reason is because it's seldom feasible to test every line of code in a software, getting 100% line coverage. And even if you achieve that, then you still have the concept of data coverage within that line coverage. Because if you think about it, if you have a test suite that is exercising every line of code in the system once with one set of inputs, then you can be fairly certain that the system works for that set of test cases. However, any set of test cases can be updated with another set of input data, running the same sequences, same test scenarios, but with different data, thereby stimulating a completely different set of lines of code in a different way, maybe new branches, interactions within the system that could themselves then result in new defects. So when it comes to trying to comprehensively test an entire system, it's seldom feasible unless it's very small projects. And therefore, there's always this need for trading off how we test, what we test, and prioritization between how we test different things. So in our interest then in this research on economical models is that from the previous slide, we talked about the best way of making these trade-offs. And what we mean by that is not a technical question per se, but rather this economical question that I already hinted at. How do we, in a cost-efficient way, find or create the best, most suitable tests for our system, taking into consideration the purpose of our test, what the type of system we're testing, and also other contextual factors. So what is the cost benefit of testing software? Well, in order to understand this or talk about this, we first have to understand the reasons for software testing. What's the purpose of testing a software? When we looked into this, there are some general commonalities, like the ones I've already discussed, that we want to quality assure our system to know that it's working and that both functional and non-functional requirements have been correctly implemented before we ship it to our customers. This is common to every domain, every company. However, there are also then other certain more detailed areas, like for some companies, it's more important to test certain non-functional attributes like security or performance. And we have to integrate that into our thinking then about the cost and benefit. Because if we have a certain budget, let's say, to do testing, we of course delegate a part of it for our functional testing. But if we have these additional requirements on non-functional testing, the question becomes how much of that bag of money, so to speak, should we invest also in the non-functional aspects? So it becomes once more this trade-off between cost and benefit. We also have to understand what decisions are being made concerning the software testing. So in decisions like how often do we run our tests, how often do we create tests, when do we delete and remove tests, when do we update them, etc. So understanding of the test process. And our goal here is to take inputs like that and try to model it and add an economical aspect factor to it for reasoning about when and how we do the software testing. So we are, of course, not the first people, me and the other Emil, to come up with the idea of modeling costs for software testing. There are plenty of research papers and models concerning how to do this. However, when we looked into the body of knowledge on these particular models for software testing, we noticed that a lot of them are very rudimentary cost estimations for software testing, taking very few factors into account. And most of them are comparative models where there are some typographics, etc., for comparing tool A to tool B to make some decision about one tool being better than the other, for instance, when selecting what tool to adopt. And we found that these models do not scale for the entire life cycle of individual tests or test suites. And that's what we wanted to approach here in this research. So therefore, we had to do something more comprehensive. So what we would like to add then to the existing body of knowledge is this economic consequences-based life cycle analysis model. A lot of fancy words there strung together. Word by word, they make sense together. Maybe they make sense as well. But the idea is then that we look into the entire life cycle of a test or a test suite or a tool to see, okay, what are cost benefits when it's being adopted, used, and when should when should it be abandoned? And I'll get back to that when we take a close look at the model. The idea behind the model is to provide decision support from an economical perspective to how to scale testing. So what we're trying to do in this model is basically to transform decision points into economical aspects where we can start reasoning about both costs and benefits as money. So we can compare the costs in money with the benefits in gained money. So if the benefits outweigh the costs, then of course we should do it. Common sense. So our take then, we see developing a test, and this is the foundation or basis for our reasoning for this model, is that developing a test can be seen as an investment. We're investing for the future to find defects or faults such that we can quickly address them to mitigate larger costs in the future. So the assumption here is that if you find a fault early, it will then result in a lower cost over time than if it lingers or even reaches into production or even reaches the customer. So the basic model looks like this then, where the basic assumption is that creating a test or adding a new testing tool or a test suite is an investment into a certain utility, which is offered then by the test tool or test suite that we do today in the hopes of being compensated somehow for that in a net benefit in the future. And in a functional form, it can be expressed then mathematically in this formula, where I is the cost of developing the test or adopting the tool or developing the test suite, whilst ECF is the expected benefits from the tests. And finally, then K denotes the opportunity costs of using the resources for developing the test. And for those of you that don't know what an opportunity cost is, that is the potential benefit we can get over time, given that we make the right decisions. I'll get back to that in a little bit in a moment. But here, as you see then, the main aspect of this formula, even though you might not understand all the mathematical details, I sure don't. Me and math, we're enemies. That is why I have the other Emil, who is really good at math. So he should have been here to explain this, but I'm doing my best here. So the main thing here is that both I and the sum equation or some part of the equation to right, both deal with money. So when it says there denotes expected benefits from the tests, those benefits are recalculated from just being, general benefits of higher quality or more customers into a tangible monetary value. So for instance, assume that we create a test in order to test some API. We assume that this API is part of some new part of the software. Then that new software will give us new customers. Then we can estimate how much value in money does that new API then provide us, and therefore how important is it to us. And that is input that we can use in this formula to calculate how much testing we should do for the API. So, and the counterpoint here would be then the opportunity cost, where we would then calculate, if we do not add the tests, what's the chance that we will add defects to, let's say, our API in this example, that results in this new functionality not being usable by our intended users, and therefore miss this opportunity to get new revenue. So basically what we're doing here is that we're taking a cost that is quite tangible in terms of just estimating the development cost of the test or implementing the tool, and then estimating the potential benefits of adding these tests contra the problems that might arise if we do not create these tests. So in essence, and this is then going back one step to once more the underlying theory, what is economics and why are we applying it here, or how are we applying it? Well, in essence, economics is the study of how scarce resources are to be used and optimized in a certain way to provide us with the optimal output. And if we put this into a time perspective, as we're doing here, where the scarce resource is the tests themselves, or the time available to create these tests, rather, we can look into investment theory for the modeling. And that is exactly what we've done here in this model that you saw, the mathematical model. That is completely taken from investment theory, from industrial economics, and then just transformed in order to fit the concept of software testing. So to test software is then an option which leads to a new option. So what I've talked about so far has been like, if we want to create or add a test or a tool or a test suite, we could use that function for that. However, we could also use that mathematical model in an incremental or an iterative process, because as we are adding a new test case or a new tool is best to reason about here, we are also adding new test capabilities to our organization. And this provides us then with new options that can lead to new opportunity costs in the future, right? Or lowering opportunity costs. So the value here is determined by the formula, as I said on the previous slide. So what we want to add here is a different mindset reasoning as well when it comes to software testing. It's not just that, oh, think about money when you're adding tests, but there's also a sequence here of sequential decisions that we want to instill into both developers, managers, and testers that is a little bit different from today. And this starts with decisions when to develop a test, taking into consideration the economical reasoning as well as the other aspects of what we're trying to achieve in terms of quality and what we need to test, the purpose of our test, but also this economical aspect. But in addition, that you keep reasoning about this when you look into existing tests as well. So if you have an existing test in need of maintenance, once more, the same reasoning that I just talked about, if should we maintain this test for our API that was so important, that same reasoning can be done for maintenance, but also when you see instances of potentially upgrading your tests. And I'll get back to this upgrading a little bit later in the presentation, but upgrading in this instance would be that we have an existing test that is working, but we see the opportunity of improving it. That's different from maintenance, where maintenance is more that we have an existing test. It is currently not testing the system in the right way, either because the requirements have changed or the test has become invalid in some other way, so it requires maintenance. But upgrading would be that we could gain new capabilities with the same test with some changes to it. For instance, new input data or some other algorithm or whatever it might be. And then finally, which is also not so common in industry, is when do we abandon tests? When do we throw them away? And I'll get back to that as well, because we found some interesting results for these two last points from our empirical evaluation. So you've now seen the mathematical formula. Here is a picture of what the result of applying this function could be. This is a theoretical example, and it could be applied for either a test suite, or a test tool, but it's just for visualization purposes, so you can get more of an understanding of the model in general. So what we have here is, on the x-axis we have time, and on the y-axis we have the cost minus benefit of adding this test tool or test suite or approach or whatever it is. And in the beginning, in T0 to point T1, this is where we're adding this new technique and then gaining the most value out of it. So when because we assume here in this model that the reason why we're adding something new is because we have an inherent need for it. And since there is an inherent need, we also get the most benefit here in the beginning of applying the approach. Once the approach is then adopted, or the test has been implemented, or it's up and running and giving us feedback, between T1 and T2, there is then, in a best case, a constant value provided by it, where the cost and value are sort of the same. And this is preferably best case scenario, where the test provides as much value as we have to put into maintaining the test. In a best case scenario, of course, the line between T1 and T2 would have been following the alpha curve instead. The alpha curve in this case is the optimal value we could have gotten from it theoretically from the test, given that it keeps reporting failures to us without needing any maintenance whatsoever. And that is how it would provide optimal value. However, in a more realistic scenario, we see it from T2 to T3 that there is a sudden dip in the value versus cost. And this could be because we have changed requirements or changes to the system that requires us to do significant maintenance to the test case, maybe rewriting it from the get-go. And what we see then there is that we have a dip, and then we have a positive curve going upwards again, where we once again assume, similar to T0 to T1 in the beginning, that this new test case that we have now maintained and fixed, or maybe upgraded, provides us with some additional benefit that outweighs its costs. And then when we get then to T3, we have reached a point between T3 and T4 where the test has aged so much that, or degraded so much, maybe due to extensive changes to our system, that we keep losing money or value from keeping the test over time. And when we then reach stage T4 to T5, that is when we really have to start thinking about taking the decision of throwing the test away, that no longer waste money on updating the test case rather than to throw it away. Not store it anywhere, not keep it, just throw it away. And I'll get back to this abandonment part in later, as I said, because this is something that is very interesting to study. But anywho, so that is sort of and as you see here, then this model then coming from the equation that I presented earlier follows the entire life cycle then of the test case, tool, or test suite. We can see the same pattern for each tool, even though this graph would then maybe be more repetitive. It's not necessarily that we only have one T1 to T2 cycle or one T2 to T3 cycle. It could be many of these. But at the start, we have this initial gain in value, and in the end, we need to throw it away because we have this complete loss of value. So just to explain the alpha and beta curves that you saw a little bit, the alpha curve, it depicts the opportunity cost. So it's the foregone benefits of an option not taken, right? So, and of the resources used for test development. So in essence, what the opportunity cost shows us here is if we keep making the optimal decisions, that is the optimal value we will get from the tests. And of course, this line is theoretical because we would then seldom be able to achieve tests that keep giving us only value without any maintenance or any other costs put into them. But it's still there as to show like as a baseline, so to speak. The beta curve instead is the lower curve, and that curve sort of indicates when the expected value from reuse of this resource, being the test or test tool or suite, when that connected to test case aging, when we have to think about abandoning our test for sure. And if you mention is note here at point T5, that is when this curve that we plotted finally crosses the beta curve value, and that is when we know that we no longer get any value from the test case, and therefore it should be removed and maybe replaced with something else. So the y-axis here, as I mentioned, denotes then the benefits minus the cost. So it calculates here what the as long as the derivative is positive, we're getting a net benefit. As soon as it's negative, we get a net loss. So a question then remains. Does this model fit reality? Well, I've sort of told you that yes, this seems to fit different tools and processes and ways of working, but how do we know? Well, in order to investigate this, we did an empirical study, which is still ongoing, where we're doing interviews with a lot of different companies. And we're asking them about their development cycle and their life cycle test cases. So when it comes to test development, the first thing we asked about was, what's the reason for why you develop test cases? And what we learned was coverage, 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 and again, coverage. The main reason for developing test cases seems to be to improve test coverage. There is no other deeper insights given there, like for instance that we want to improve some certain type of coverage, or rather coverage of a certain quality of the system that I mentioned, for instance, but rather than that, it's primarily like improve line coverage, improve coverage in general. We also saw then when it comes to test development that it's quite often predefined time budgets for test development, meaning that in a sprint, even if it's agile, there is always time allocated for this test development. And that is then the allotted time and cost that is allocated to creating the test. And that is then very important input for this model, because it would then help us then to prioritize the cost benefit in terms of a certain budget. And however, in general, when it comes to test development, because we learned also, even though there are budgets, these budgets are often flexible in many companies and many projects, where development is always prioritized over testing, even development of tests. So what we learned was that the priority number one is always to create more test cases. Number two is to maintain existing test cases. Number three, to update existing test cases to improve them. Very seldom happens. And abandoning test cases, removing them, seldom never also happens. And I'll get back to that once more. I keep hooking back to this abandonment of tests because it's super interesting, but we have to wait 2 more slides. So what we also found then when it came to test development was that there is really very little to almost no discussion regarding the measured benefits in terms of money when it comes to creating tests, or rather benefits in general. Rather, the benefit itself seems to be improving coverage. But if just because you have higher coverage of lines of code doesn't mean necessarily that you have good tests. Remember what I mentioned about data coverage as part of the test suites as well. And just because you stimulate the system in one set of with one set of inputs doesn't mean that you find all the defects. You might need to do it with another set of data as well. And that is then something that should be considered when you decide upon if we should develop a test or not, because it's part of the test's purpose. When it came to maintenance and to asking people in different companies about this, we found that the main reason for doing maintenance was to change or update the test according to code changes or requirement changes, which makes sense. We need to align our tests with the code and the requirements. We also learned then that practitioners think that this should be done continuously, but in reality, it often happens when there's time available. Remember what I'd said on the previous slide, that creating new tests is prior number 1, especially in companies that have adopted this shift left paradigm where unit test creation stuff is pushed upon developers. There is still this priority of creating test cases. And when it comes then to test departments and testers, they prioritize then running tests, and then what time is left is spent on maintaining the tests that are available, making sure that the test suites at least test what they're intended to do. So just maintaining the bare minimum to make the tests run in the existing environments. Once more here, no real discussion about how to measure benefits. For instance, if you have 10 broken test cases, you might have limited budget, as already mentioned. How do you prioritize which test cases to maintain first? Or should you maintain all of them all the time, etc.? Very little is given from the interviews in terms of this, how to reason about that. Then we have this more alien concept of updating tests, making sure that tests that are still working or sort of working, how to make them better. And here we actually got no reasons to update tests because we learned that very few companies actually do this. When companies have, most companies that we talk to have a mentality, a mindset of doing constant refactoring of their source code, of their software, improving it, improving performance, removing code smells, etc. However, when it came to automated tests or tests in general, very few did anything similar to that for their tests, because the tests were not seen as a coding artifact, as a equal standing artifact to the source code, where such activities are encouraged and important. For the tests, not considered so important. So one of the reasons that was mentioned then as sort of a way of maybe defending why tests are not updated was to try to maintain some low complexity within the tests, not adding complexity by making more advanced but better test cases, but rather keeping them simple and as stupid as possible to be able to run them quickly and make them easy to read and maintain. The reasons for doing updates, which were in a few cases at least, was that when test code was updated, so the reasons to update it was once more driven by code changes. So there was almost no difference between maintenance here and updating things. But it was more in the sense of if the code that a certain test is testing is being updated, then how can we improve the test as we're doing maintenance in order to cover more of the new functionality or existing functionality? So a little bit of it going on, but very seldom. And then now we come to test abandonment. And this is the one that I've sort of been catering for several times. We asked about what's the reason for abandoning tests. And we learned here once more that there were really no answers to it. Some companies do abandon test cases, meaning removing them altogether. Some do not. And the reason for not doing so, well, really no discussing regarding costs when thinking about it. And when doing it, it was important to know what tests were run and where. So in general, when it comes to tests that are aged, that are getting older, that are no longer providing value, they are sort of kept around, allowed to live, and continuous cost is poured into them to make sure that they are maintained for the simple purpose of it could be good to have in the future. It's part of our safety net. We've already poured money into it. We have sunken cost into having this test tool, whatever it is. It's providing us with zero value in terms of finding new defects. Hasn't done so for a long while, but just in case it might find the defects in a month or so, let's keep it around. So what we learned is that tests are then never deleted. When tests are removed, abandoned, they're generally just moved to a shelf somewhere, as there's this picture of someone hoarding everything. You just throw it into the closet together with everything else. You will probably never use it again. You will instead just create a new test. But it's always good to have it there just in case we want to run a larger system test or whatever it might be. Then we might bring it back to run it. And yeah, once more didn't find anything, so we throw it back into the pile of garbage, right? And the reasoning here is then that, okay, but that seems fine, right? Just keeping that test around, it doesn't cost anything. Well, there you're wrong. And that is something that our model actually takes into consideration. First of all, you still have the sunken cost problem. You keep maintaining these test cases, even though you run them very seldom. So that's the first part. If you keep doing that enough, then your developers will probably figure out that, okay, we keep maintaining this test, but it doesn't really give any value, then it will be thrown away. However, even if you don't have to do any maintenance, the test is still costing you money, because there are hidden costs that no one considers. It's taking space on a hard drive somewhere. That hard drive, both the hard drive and the hardware which is executing the test cases, every time you bring that test back, it's costing you, well, essentially electricity. And that adds money to its cost. That test keeps costing you money, both for storage in the electronic environment and for execution from time to time. This may seem like a minuscule amount of cost, but scale this to hundreds of thousands of test cases, and add on top of that the need for prioritization and other algorithms that are just there to continuously exclude this test case from being run because there is no time to do it, then suddenly the costs ramp up. And that is something that can be covered by the model that I've shown you here, and something that we would like to investigate more in the future. So a test abandonment is an interesting factor. That's something that very few companies actually do. If the things are abandoned, they are not removed. You keep it forever just because of you sunk cost into it. We cannot just throw it away. So some conclusions then. There is little reasoning concerning economics when it comes to testing. It's not often seen as from a managerial perspective, and there is still a lot of emphasis when it comes to software testing on the technical decision making. What tools should we use and what tests should I do today? But there is no reasoning of why I should do this test. What's the purpose of the test that I need to create, for instance? And how does that impact if I should create, let's say, a high-level test, let's say a system test or a unit test or an integration test or something in between? However, when we look into the empirical evidence, we see then that at least the general process that we see in the different companies fit with the model that we're developing, although it seems that there are some phases of our model that are not considered as much. As for instance, the updates, as well as the total abandonment, removal of test cases. More emphasis in the development process of testing, or for testing, is the development and maintenance parts of creating tests. Updates and removal, not so much, even though these are important phases of a test life cycle that needs, we think, to take more precedence in reality or in practice. So some quick future work. We will continue to confirm the validity of our model through more interviews and working with companies. Then we want to fine-tune our models, and then also create suitable proxies for the benefits and translating benefits into costs for the modeling, for the cost value evaluation, and then also try to see how we can apply this model in a continuous environment by automating it, basically. So with that, I thank you for listening. And we have, I think, 5 minutes for questions. So yeah, shoot. Thank you.
Thank you, Emil. I would say.